Okay, so this video is going to be over kinematics 1A. This section of the unit is related to units, constant velocity, and then average speed and average velocity problems. The plan is that you're going to take notes over this section, work on a practice worksheet, and then you're going to take a quiz over this section. And so this is the introduction to kinematics. And kinematics is basically a part of physics that studies motion without worrying about what causes the motion. Now, later on, we'll talk about forces and Newton's laws that has to do with what causes motion, and that has to do with what's called dynamics. Kinematics is just the study of motion without caring about, why things are moving to begin with. And so kinematics has to do with concepts like distance and displacement, speed and velocity, and acceleration. And normally we would talk about distance and displacement and speed and velocity and the differences between those two things. But just because we're doing this course in a different format, we're going to skip the discussion of that now and only talk about the very basics of these concepts. Now, in this course, we're going to talk about two primary types of motion, constant velocity and constant acceleration. And there's lots of different things, there's lots of different ways objects can move. And so these are only two types of motion, and they're very simplified types of motion. But you have to start with the basics before you can do more complicated types of motion. And so in this video, we're going to mainly focus on constant velocity, but we're also going to talk about average speed in a few minutes. Now, before we get to constant velocity, let's really quickly talk about units. Now, units are basically how you measure quantities. And in physics, we use specific scientific units, or SI units, to measure different things. So, for example, there's different units of time. You might measure time in years, or days, or hours, or minutes, or seconds, or centuries. In this class, we're going to use the SI, or the scientific unit for time, which is the second. Now, it's really important that you know what the different units are, because a lot of the time when you're doing a problem in physics, you can immediately identify what a given quantity is based off the unit. So for example, if it says something is 5 seconds, 5 seconds, that's got to be time, because nothing else has the unit of second. So the unit we're going to use for distance and displacement is going to be the meter. Okay, that's typically written with a lowercase m. Now, again, there's different units for distance and displacement. There's inches, feet, miles, kilometers, centimeters, but we're primarily going to work in SI units, and so we're going to use the meter for distance and displacement. We're going to use the second for time. For speed and velocity, we're primarily going to work in meters per second, which you write meters per second with the m/m. That's for meters per second. And the unit for acceleration is the meter per second squared, which you can also think of as meter per second. And we'll talk a lot about acceleration in a different video. But meters per second squared is how you would read that. And again, these are not the only possible units for these quantities, but they are the units we're mainly going to use in this class. Okay, so if you see something and it's like 28 meters per second squared, you should look at the unit, say, oh, okay, meters per second squared is the unit for acceleration, and be able to identify that as the acceleration. So it's really important that you understand what different units for different things are. Okay, so take a good look at the slide, take down any notes you need to, and then we're going to move on to constant velocity. Okay, now constant velocity, there's lots of different ways an object can move. The easiest possible way for an object to move is with what's called constant velocity. And basically, to move at constant velocity means you're moving at a rate that you're not speeding up or slowing down. You're basically moving in a straight line at a set pace. Okay, so for example, if you ever drive on the highway and you use cruise control, you can set the cruise control for a certain speed, and when you take your foot off the gas, your car keeps going at that same speed. Okay, and so that's an example of moving at a constant velocity. Now, because constant velocity is the easiest type of motion, there's only one equation having to do with constant velocity. There's only one equation that you need to know to solve problems with constant velocity. As we'll see when we talk about acceleration, the more complicated motion there is, the more equations you need to be able to solve problems. The constant velocity equation is very, very easy though. Here it is. Okay, it's here at the bottom. D equals V times t. This x just represents multiplication. So d equals v times t. Now, in this case, d represents distance or displacement, as you might imagine. Okay, v represents speed or velocity, and then t represents time. Okay, and so as long as you have a problem with constant velocity, it's very, very easy to solve just because it's a very simple equation. You only have three variables, d, v, and t, in the equation. And so constant velocity problems are very easy to solve. So what we're going to do now is we're going to look at what this might look like using a simulation, and then we're going to do some simple calculation problems. Okay, and so this is a simulation called the Moving Man, and you'll be playing with him in another activity later on. But just to show you what constant velocity might look like, here's my Moving Man. And if I set his velocity to 1 meter per second, and I hit play, notice the way he's moving is he's moving to the right. He's not moving any faster or slower. He's just moving at 1 meter per second, meaning every second that passes, he travels a distance of 1 meter. And then he hits a wall, and he stops. Now, if I give him a negative velocity, let's say negative 2 meters per second, this is still constant velocity. Notice now he's moving to the left. He's moving in the negative direction. And so velocity is something that can be positive or negative. And whether it's positive or negative indicates direction. So negative 2 meters per second, this is still constant velocity, but now he's moving to the left in the negative direction. Okay, and so that's what that type of motion would look like. And again, there's lots of situations. This is 4 meters per second, so he's going faster to the right because it's a positive velocity. There's lots of situations where you might see constant velocity in real life, but it's a very simplified type of motion, and you don't see it too often in real life. But that's what we're going to start with. So let's do some simple examples with constant velocity. This problem says a bunny hops along at 0.35, and look at the units. m/s, meters per second. Okay, now I think to myself, what has units of meters per second? That's got to be speed or velocity. And so I'm going to label this with a v for velocity. Now I keep reading. How far is the question I'm being asked? Will the bunny travel in 4 seconds? Okay, I look at the unit, I say, okay, 4 seconds, that's got to be time, so I label that with a t. And the question, how far, is always going to be asking about displacement. Okay, so d is my unknown. I use my constant velocity equation. D equals v times t. I'm solving for d, and so now that I've identified my variables and I have my equation written down, all I'm going to do is I'm going to plug into my equation and solve. D equals v. I'm going to plug in now. I'm going to plug in 0.35 for the velocity, 0.35 times t. T is 4 seconds, so I'm going to plug in 4, like that. And a lot of the time you have to do algebra to rearrange this. In this case, all I have to do is plug this into the calculator, and I get 1.4, and the unit for that is meters. And by the way, when you're doing problems and assignments in Canvas, you don't have to put the unit, you just have to put the number. Or technically, the unit should be the meter. Okay, so 1.4 meters is the answer for example 1. Okay, so let's go on to example 2. Pause it there if you need to. Okay, so example 2 says a race car speeds down the highway at a constant velocity. By the way, I'm looking for those context clues all the time. Constant velocity, there's one equation for constant velocity, and that's the d equals v times t equation. Okay, if it travels 3,500 meters, again, I'm looking at the unit. I know meters is the unit for distance. Okay, so I'm going to label that with a d. 60 seconds. Based off the unit, I know that is my time, so I'm going to label that with a t. And I'm looking for the velocity. The question is saying, what is the velocity? And so my unknown is going to be v. I take my constant velocity equation, I substitute in, I plug in place of d, I put 3,500 equals v I leave v in there because I don't know what v is. V is what I'm solving for. And so I don't know what v is. I just leave that in my equation. And then I plug in for t. T is 60 seconds. And so now I need to rearrange this and get v by itself. So I ask myself, what is being done to v? Well, v is being multiplied by 60. So to get v by itself, I need to undo that multiplication. And the opposite of multiplication, the way I undo multiplication is by division. And so I'm going to divide both sides by 60. Okay, if you're multiplying by 60, you need to divide by 60 to get rid of that. And if you do it on one side, you have to do it on the other side. So the answer to my question, what is the velocity of the race car? V is going to be 3,500 divided by 60. And then I take my calculator, and I get 58.3, and the unit for that is meters per second. Now, if you actually type it into the calculator, you get 58.333333. You typically only need 1 or 2 decimal places. When you're doing assignments in Canvas, the question should tell you how many decimal places your answer should have. But typically, you're free to round as long as you keep 1 or 2 decimal places. That's fine. Okay, so you don't need to write out all the 3's. That's a waste of time. So this is the answer to example 2. And hopefully you see that constant velocity problems are very, very simple. There's not a ton of math involved, just some very basic algebra. Okay, so let's do another example. Pause it here if you need to. Okay, one more quick example, just to show you that the equation works even if you were not dealing with SI units. It says a family taking a road trip travels at a constant velocity. Okay, that means I need to be using my constant velocity equation of 60 mph. What is mph? Well, hopefully you know that mph is miles per hour. Now, miles per hour is not the SI unit for velocity, but it is a unit of velocity. And so I'm going to label that as v. And they give me the time not in the SI unit of seconds, but they give me the time in hours. Okay, so that's going to be my t. And so this constant velocity equation works with different units as long as the units kind of go together. So miles per hour, that means the time also has to be in hours. If it was miles per second, the time would have to be in seconds. Okay, and so the question says calculate how far. That's a question about displacement or distance, so that's going to be my d. How far the family travels, d equals, and I'm just going to plug in. V is 60, t is 0.5, and so d is going to be 30, and if this is miles per hour and this is hours, this distance is going to be in miles. And so that's just to show you that even though most of the time, 95% of the time, we're working with SI units like meters and seconds and stuff like that, the equation still works in different units. Okay, so that is example 3. Okay, the last thing we're going to talk about really quickly is average speed. And average speed comes up in situations where objects are not traveling at a constant velocity, but they actually travel different distances in different times. And this is useful because there's lots of situations where you're going on a trip and different parts of the trip take different amounts of time. And so this brings up the concept of average speed. Now, the way you calculate average speed is very simple. Okay, to calculate average speed, you use this equation. And the equation says d total over t total. Okay, d total is the total distance that the object travels, and t total is the total time that the object travels for. Okay, and again, you would use this in situations where you don't necessarily have constant velocity over the entire trip. Okay, so let's do 2 quick examples, and then we'll be done. So, example 1, a boy walking to school from his house stops by the store to get some candy. It takes him 0.55 hours. Based off of the units, I'm always looking at units. I know that this is going to be a time, so I'm going to label that with a t. And it takes him 0.55 hours to walk 1.6 miles. I'm going to label that with a d because that's obviously a distance because it's in miles. And then it takes him another 0.62 hours So look, I have another time now. I'm going to label that the t, and just to tell them apart, I'm going to label this t t1 and this t t2. Okay, so I have two different times. Okay, so it takes him a certain amount of time to go to the store, and then a certain amount of time to walk to school. Okay, so t1 and t2. And then this is going to be the distance to school. I'm going to call this d2, and I'm going to call the first distance d1. Now if I want to find average speed, okay, the equation was on the last slide. Average speed, I'm going to write S average for average speed, is equal to d total divided by t total. Okay, so this is a different equation than the constant velocity equation. Again, you use this in situations where you're taking a trip. And you can always spot average speed problems because number one, it'll say average speed, and number two, you'll see like different times and different distances like this. So if I want to do this calculation, in place of d total, I'm basically going to have to add up all the distances in the problem. So in this case, I have two distances. I have d1, which is 1.6 miles, so 1.6, plus d2, which is 1.3 miles, and then I'm going to divide that by t total, which is the total time. Okay, so I have two different times I'm adding, 0.55 plus 0.62. Okay, now I'm going to type this into my calculator to get the answer. By the way, just something funny to point out to you. Notice that even though the distance to the school is actually less than the distance to this store, it actually takes him longer to get to school. So probably because, well, the boy probably doesn't want to go to school. So on the top, 1.6 plus 1.3 equals 2.9. On the bottom, 0.55 plus 0.62 equals 1.17. And then all I'm going to do is I'm going to divide the total distance by the total time. And if you do that, you should get 2.48. And that's going to be miles divided by hours. So that's going to be miles per hour. And again, when you're doing assignment on Canvas, you don't need to put the units, but it is miles per hour because I'm dividing distance in miles divided by time in hours. Okay, so that is an example problem with average speed. Okay, again, very, very simple as long as you can correctly identify all of the distances and all of the times. Okay, so we're going to do one more example, and then we'll be done with the video. Okay, so pause it there if you need to look that over. Okay, so one more example. Pause it here, and I want you to try to answer this question on your own. Okay, so this is going to be example 2. So see if you can answer the question on your own. Okay, so let's do this real quick. A man running a race runs in 3 different segments. During the first segment, he runs 40 meters. I know meters is a unit for distance, so I'm going to label that with a D. And that's the first distance I saw, so I'm going to call it D1. And this is the time that goes with that distance. So I'm going to label that T1. I know it's time because it's in seconds. During the second segment, he runs 100 meters. Okay, again, that's the distance. By the way, if you don't know what a meter is close to being a yard. It's not quite the same, but it's around a yard, in case you want to know what a meter is. Okay, so I'm going to call that D2. And the second time, I'm going to call that T2. It doesn't really matter what you call them because all we're going to do is add up all the distances and add up all the times and divide them anyway. So I'm going to label these last 3. So the average speed is going to be equal to the total distance divided by the total time. And while I write that out and plug in my numbers, again, I want to remind you this is a little bit different than constant velocity because technically speaking, we don't have constant velocity during the entire time because he's running faster in some segments than he is in other segments. And so we use the concept of average speed to help deal with these situations where we don't necessarily have constant velocity for the entire time period. Okay, and so this is what you should have, and then all you have to do is plug this into the calculator, add up all the numbers on the top and all the numbers on the bottom, and divide. And if you do that correctly, and hopefully I did this correctly, you should get 6.04 meters per second, and it's meters per second because I'm dividing the distance in meters by the time in seconds. And so hopefully that's the answer you got. If you have any questions, please let me know, either through Edpuzzle, or you're welcome to come see me in Zoom or send me an email. Okay, I hope you enjoyed the video, and I will see you guys in the next video.